All right, guys, while it's not crucial to the understanding of this problem, I thought I'd make you a quick video on setting up the initial ice table and making sure that you can get the equilibrium concentrations, because a little extra practice doesn't hurt. Now, the problem tells you that you have 0.01 moles in 100 milliliters of solution. I've gone ahead and converted my volume there, but that's what we ended up with. Okay, so I'm going to set up an ice table. And in my ice table, I'm going to put everything in terms of molarity. So I'm going to combine these values. I'm going to divide 0.01 moles by 0.1 liters. And I'm going to get a value of 0.1 molar, right? I'm going to leave them out of the table so it's easier. 0.1 molar. And at the very beginning of my reaction, I don't have any of that. I also don't have any C, but I don't care because it's a solid and it's not going to show up in my equilibrium constant expression. So now I can set up the rest of my ice table. I didn't initially have any AB, so the initial concentration 0, which means I'm going to need to add X to that side, because if I subtract it, I end up with a negative concentration. And if I add X to that side, I'm going to have to subtract it from these others. So now I have all of my equilibrium concentrations in terms of X. If I set up my K expression, and I know K is equal to 2 times 10 to the minus 5. I have products, which are AB, over reactants, which is A and CB. And if I take a minute to plug in the equilibrium line expressions, I end up with this. Now, A and CB happen to be the same, so I just squared it for simplicity. Now, if you compare that concentration there to this K value, this exponent is going to be so far away from that initial concentration that if I go through the whole quadratic formula thing, I come out with a value of X small enough that it does not really change 1. So I'm going to simplify my expression, and I'm going to say that really all I care about is the 0.1. I still have to square it because I have to take A and CB into account. And so now I've simplified my K expression, and it still equals that K. Square that value, multiply that by 2 times 10 to the minus 5, and you get a value for X that's 2 times 10 to the minus 7, and that's molar. So this X is actually the concentration of AB at equilibrium, and this X is so small that at equilibrium, we're going to still just really consider these guys 0.1. If I would like to double check my values and make sure that I have calculated everything correctly, I can plug what I have into my K expression. And I can even be really as accurate about it as I can be, and I can go ahead and put that 2 times 10 to the minus 7 in there. I still have to remember to square it because I have A and CB. And when I do that, I get the value for K that's reported. So that is how I got the equilibrium concentrations for the first equilibrium that was established. Not before we changed the volume, just that first equilibrium that was established.